Alright, my rock stars, this is section 3.4, lines and linear functions. Let's say you wanted to graph y equals negative 2x plus 30. Here's one way you could do it. You could just make a data table of values, plug in negative 3, get out 36, because negative 2 times negative 3 is positive 6 plus 30. So you plot the point negative 3, 36, right here. Similarly, you would plot 0, comma 30 here. And scrolling things up a little bit, you would plot 10, 10, 10 here, and connect the dots with a long straight line. Boom, you're done. Other people might also think about looking at this negative 2 and this 30 and remembering you can always plot a point here. The easiest point to plot is with 0 because it's just 0, comma 30 right there. And then remembering something about slope, you can go, you can fall and crawl. You can fall, for example, 2 blocks and crawl 1 here. Fall 2, crawl 1. In any case, you get a straight line. Here's another way to do it. If you have a function that looks like this, 2x plus 3y equals 18, all the variables on one side, I mean, you could move the 2x over, divide all the terms on both sides by 3 to get y equals something. But maybe this would be a little easier. You take 0, plug it in for x, and figure out what y is going to be. 2 times 0 plus 3y equals 18. That turns into y equals 6. 6, so plot the point 0, comma 6 here. Then take 0 and plug it in for y. 2x plus 3 times 0 is equal to 18. So therefore 2x is equal to 18, and therefore x is equal to 9. And get this point here. In any case, there are the points, and you connect the dots and you get a straight line. These are called intercepts. The top one here is called the y-intercept because it intercepts the y-axis. Even though the y itself is not 0, y is equal to 6. X-intercept is down here when you have the point 9, comma 0. Something we need to remember is slope. Here's how it's defined. The formula is right here. y2 minus y1 over x2 minus x1. So you've got here, and the way you get it is, you can see you've got this length, and you divide the two. This is actually called the rise, and then one formula is rise over run, where the change in y and the change in x here. The change in y, change in x. So linear functions can look like this, where you've got the slope and the y-intercept right here, the y-intercept and the slope. If the slope is 0, then it kind of degenerates. If this is 0 times x plus b, then it just turns into y equals b right here, y equals negative 2. This horizontal line is here. It has its formula y equals negative 2. That's the opposite of what you might expect. You might expect y equals negative 2 to be vertical because the y-axis is vertical, but it's not. It's the line that is 2 units down along the y-axis. And here, a vertical line, x equals 4. The slope here is so steep, so high, that you can't even quantify it. It's not a function. It fails the vertical line test. And the slope is not calculatable. You can't find a slope. When you ask the question, what is the slope, there is no real answer. It's undefined. So you can say x equals 4 because it's the line that occurs 4 units over along the x-axis. In this example, we have to graph the function f of x is equal to negative 2/3 x plus 1 and determine the slope. Well, I'm going to cut to the chase right now. The slope is going to be negative 2/3. You can see that in the function. Just read it right there. But if you wanted to actually calculate it and look and find it, this is what it would look like. Besides, if you wanted to graph it, you would need a couple of things. You could, for example, graph the y-intercept and then fall 2, 1, 2, and crawl 3, 1, 2, 3. Fall 2, and crawl 3, put a dot. Fall 2, crawl 3. I'm saying fall and crawl because of the negative slope right here. If you needed a table of values, you could also plug in 0, because we know that 0 will cancel out. You get 0, 1, and you plot the point here. Plug in 3, these would cancel, and you get negative 2 over 1 plus 1, which is negative 1, and plot that right here. 6, 6, negative 3 is right here. 6, negative 3, and then 9, negative 5 is right here. A lot of Algebra 2 students, I find, don't use the table, and that's fine. However, when you have something more complicated, like a quadratic or cubic function that you need to graph, a table of values comes really handy. So make sure you use it in your arsenal of tricks when it comes to graphing. When I ask for a graph, I write equation, table, and then graph here. Unless you have a shorter cut, like y-intercept and rise over run. So here's how you calculate slope. A strategy to make sure you don't mix up the x's and y's. You can label them here. It doesn't take very much time, and it's only a little bit of handwriting. But if this is going to be x1, just mark x1 here, y1, x2, y2. So when you get to the formula, you can plug them in correctly. y2 is negative 5, it goes here. y1 is negative 1, it goes right here. And the tricky part is the subtraction. Negative 5 minus negative 1 is actually negative 4. x2 minus x1, x2 minus x1 here, 9 minus 3, you get 6. That's negative 2/3. Here's another formula that you might have had in Algebra 1. If you want the equation of a line, if m equals 3 and the point is negative 3, 2, then you can use the point slope form, which is right here. Y minus y1 equals m times x minus x1. And you fill in the information. Again, I enjoy labeling this x1, y1. This is negative 3, y1 is right here, 2. And you can simplify that a little bit. You get here. Parallel lines. If you see these lines here, they are parallel. They're like railroad tracks. If you keep on going, they'll never intersect. Never intersect. Wait, there's an intersection. It is not parallel. One thing you find about these slopes is that they're equal. This is a slope of 2, slope of 2. Slope of 2, slope of 2. And you see they have different y-intercepts. These 4 and this negative 3 have nothing to do with each other except the fact that they're not the same number. So you can say that the slopes are equal here. Therefore, you know that it's parallel. Here, the slopes are both undefined, so then they're also parallel. But here, check this out. 3 is not equal to 1/2, so therefore the lines are not parallel. Even though the intercepts, negative 2 and negative 2, are equal. So slopes are equal if you're going to have parallel lines. Perpendicular lines are a little bit more tricky. Here's the symbol for perpendicular. You can use that if you want, as opposed to just writing out the word perpendicular. It's a long line. It's a long word. So you have to make sure the slopes are both opposites and reciprocals. There's 2 requirements. The slope has got to be opposite. You have to have both a positive and negative represented in the 2 slopes. And then they've got to be flipped versions of each other, reciprocals. So check this out. It's like this. 3 over 4 is the reciprocal is 4 over 3. You've got 1 positive and 1 negative. Fine. These are perpendicular slopes. These are perpendicular slopes because you've got a negative and a positive, and then they are reciprocals of each other. They're flipped. Again, here, these 2 slopes are going to be perpendicular because you can take negative 4 and you can always put it over 1, and then all of a sudden you see that they are reciprocals. Great, and you've got a negative and a positive. These are not perpendicular. Although they are reciprocals, they're not perpendicular because they're both positive. It's lacking a negative slope. Where's the negative slope? It's not perpendicular. Here, you've got one positive and one negative, and that's great, but they're not reciprocals of each other. And that's why they're not perpendicular. All right, kiddies, it's play at home time with Desmos. What that means is when I do something on Desmos, you do it too. Make sure you can show me your saved Desmos graphs when you arrive in class tomorrow. So now that the video is finished, I'd like to tell you that the capital of California is Sacramento. It's the site of the only marathon I've ever done. Great city. Let me know if you've ever been there. So begin 3D, do the first problem, and copy the assignment list. I will see you in class.